The topic of our today's discussion is the complexities of working with ES in distributed systems on the real project. Uh, I believe Maxim told everything that I want to describe about myself. So as he mentioned, so my specialization and something I know about this is high-load distributed systems. The only thing why I love this topic and domain because I believe that this is the most complex and challenging domains in computer science at the moment. And high-load, never forgive and never forget, because if you miss something, you made some mistake, a system will notify you about it very soon. And few words about Bizarro. So Bizarro, this is the event experience OS, and we bring really revolutionary ideas in the event industry. And this is really important in after COVID era because many companies disappeared, but our product helped many customers to survive and even to become larger. And here you can see the list of some of our customers. And as they're real famous, we assume that we doing our stuff very well. And the short agenda for today. So first of all, we will discuss the Elasticsearch from software development engineer perspective. Then a few words about Elasticsearch basics. And after this, we will go to the most interesting part of our discussion, the real-world challenges. And at the end, I will be glad to answer to your questions. First of all, Elasticsearch. So Elasticsearch, this is a full text engine that has many useful features that makes it a really leading solution at the moment. And when someone wants to select any technology for full text search, 99% that it will be Elasticsearch. And as you know, ES is based on the Lucene library. So, and today we'll discuss Elastic from software engineering perspective, because usually when I saw some meetups, it discussed from DevOps and for logging, but ES is more wider than this. So the main features of Elastic are, so first of all is clustering, then caching, and then REST API. Clustering, this is term that defines when different nodes are connected in the group, and it calls cluster. It gives you ability to work in distributed system very well and to tune your environment as you want. Also caching that helps you to improve your performance. As you know, we have three levels of cache. This is page cache, shard level request cache, and query cache. And also very important, this is REST API. It's very convenient, it's full RESTful, and it's well documented. And also you can see that it has a wide community that, and you can find answers to almost any questions that you can face with during work with ES. Let's go a little bit deeper in the Elasticsearch. So in Elastic, under the hood, this is implementation of inverted index data structure. So how it works? So let's see this example. So for example, we have three strings. So string 0, string 1, and 2. 0 is it what it is? What is it? And it is a banana. After processing, we have the list that you can see at the middle of the slide. So we have A2. It means that A exists in string 2, banana. 2, it means it, and 2, and for example, is it represented in strings 0, 1, and 2. And for example, if we will send a request, what is it? We'll get a result that will be intersection of three subsets. So 0, 1, 0, 1, 2, and 0, 1, 2. And as a result, you will get 0, 1. It means that result of this query will be strings 0 and 1. After this, Elastic able to calculate relevant scoring using its algorithm, and you will get your results. Another important conceptual question, this is Elasticsearch a database? This is quite complex question because in different resources you can find different answers. But if we'll go to the official documentation, you will see that Elastic, this is a full text search engine. And but sometimes people say that this is document-oriented database. It's not really important how we call it, but let's see these few items. So first of all, Elastic doesn't have so wide and flexible security user concept as modern database. It doesn't have transaction support. It's not as reliable as commonly used databases, and it means it's not the best idea to use Elastic as your single source for your crucial data. And also it provides you with near real-time availability and not at the moment. Let's go to the real case scenario that we at Bizarro faced on some stage. Let's imagine that you have a project and it succeeds. So you are really good, you have new customers, new users, and as a result, you have high load on your system. And when you made a decision to use Elasticsearch, you based on some documentation, on some discussions, and you made some examples that worked for you, and it's okay. But at some point, you starts to understand that real world scenarios are not the study examples, and you trying to solve them. And always you keep in mind where you grow while you are growing that you have money, and if something goes wrong, you always can scale up, scale horizontally, so you can buy more powerful machines, you can scale 20, 30 machines, and so on. But surprise, at some point it won't help, and you will still face with node crashes, with slow queries and timeouts, and split brain problem because you have a huge amount of data, you have more requests, and your implementation is not very appropriate to your current situation. So what could result in this situation? So common mistakes we believe lies in the approach. So first of all, Elasticsearch is not a cache. Sometimes I saw that engineers tries to use AS as a cache and to find data very quickly. But if you need cache, it's really better to use cache. You have Redis, you have Aerospike, and so on. So you can use appropriate technology. Also, frequent updates is your enemy because each update in Elastic, it's under the hood three operations. So this is insert operation. After this, you mark all the document as old and for its candidate for deletion, and only when Lucene will merge segments, it will be deleted hard. And also, delete by query is a really common situation, and that can really impair your performance. Also, very interesting approach, and all details could be found on the official Elasticsearch documentation and website. This is warm cold approach. So let's imagine a situation that you have many indexes in the Elastic, and five of them are really huge, and all of them are on the one machine, and it means that this machine will be the most affected because you have huge load here. And you can go next way. So you can divide all your indexes into three groups. So these groups are hot, warm, and cold. Hot indexes, this is indexes that are under high load, so you always need to write data here, you have query data here, and so on. And these indexes could be placed on the hot nodes. Hot node should be really powerful because indexing requires some CPU resources and requires input-output intensive operations. Warm indexes could be placed on the warm nodes, and warm indexes, these indexes that are not so huge for insert and update, but you still need to get them, and you can use a lower machine for the warm indexes. And the cold indexes, this is indexes that are that contains data that is crucial for you. You still need it, but it's not very often situation when you query data from it, but you still need it. And if query takes too much time, it's not a problem for you. This approach can improve your performance because you won't waste time for queries that are not critical for you, and also it will help to save you money. And when you work with high load system, especially in some cloud provider as Amazon or GCP, it would be really um, good amount of data or amount of money. Also, common mistakes that we faced, it was a too flexible functionality because nowadays business always wants to bring the best features for their customers because it's critical, and they need them ASAP. They need them yesterday, as always. And you, if you're engineer, lead or architect, you also always should not implement the first brute force solution, and you should take into account all details. And if it requires additional time, you should request it, but not implement it. And also very interesting case that we faced was connected with data consistency. Situation was next. When we had a monolith at the beginning, so we push data to the Elasticsearch. And during migration from monolith to microservices, uh, we forgot about consistency. The idea next. So we have different tables in the database, in simple relational database, and Elastic in some cases was used as some kind of views. So we collected data from different tables, we created some documents, and these documents were represented in Elastic. And on UI, you was able to get data in convenient representation. But during migration, we forgot that if you update some table, you have to update ES, and it resulted in some data inconsistency, and it took a lot of effort from our side to fix it and to monitor it. So our conclusion at the end was to audit all insert operation to ES, and after this, we fixed this issue. And as a conclusion, so Elasticsearch is a really great solution for full text search. And if you need full text search, Elastic is really good. It has a clever architecture, and it just does what you need. But you should always keep in mind that it could be really challenging to work with Elastic in distributed and high load system. Thank you.
Thank you very much, Evgeny. Short, very focused, very practical and useful session. And we had a couple of questions from our participants, and you just answered one of them. So the question was about common pitfalls, common issues. So you illustrated this perfectly well with the examples from your real project. And we have one question left. It's about how to profile queries in Elasticsearch if there are some problems with performance, for example. Any advice, any recommendation on profiling?
Yeah, sure. So just a little remarks to the first question. So if you're just starting to work with Elastic, so first of all, you should read about concepts, what it does at all, and after this, you will always face some situations that are not described anywhere, but you will work and handle it. And regarding profiling, so we have Profile API in Elastic, so I can leave the link to the Profile API Elastic, but the idea is that you just add in profile through flag into the request, and at the end you get an detailization or which time was handled for this operation, for this, and it will help you.
Cool, cool,
Yeah,
cool.
that's
How
it.
often do you use profiling in your real projects?
At the moment, not so often, but when we face some issues, we use it often because situations like so you have good evening with the family, but after this you get some call or message or DevOps knocking to your door, and you have to fix something, and you analyzing situation, and you see that the root cause of this issue is problems with Elastic, so drop down or timeouts, and you taking profiler and trying to understand what could be improved.
Got it. Thank you very much again for your session and for your answers. Let's stay connected. And
Thank you.
yeah, thanks for supporting our event with your session. Bye.